Hi friends, welcome to follow up. Let's have a look at problem 54, spiral matrix. This is a daily challenge problem, and actually we have practiced several similar problems in LeetCode. So there are 4 such problems. So here I'm going to use this problem as an example to explain the rotation matrix method. So in this problem, we are required to return all elements of a m by n matrix in spiral order. So here are 2 examples, and the examples specifies the way we're going to look at those elements. So we first walk along the first row, and then at the end of the first row, we change direction. So we walk along the last column. Then if we arrive at the last row, we're going to decrement the the column index towards left, then above, and then right. So this you can also look at example 2. So to digest the requirement. So here the constraints are the following. First, m and n are the matrix rows and columns, number of rows and number of columns. So m and n are both in between 1 and 10. And the elements in the matrix are bounded in absolute value by 100, right? So with that said, basically we are ready to explain the method. So in this problem, the key thing is that we want to track how we get the next elements, right? So if we use dr dc to represent the direction. So if we walk on the first row, so dr dc will be 0 and 1. In other words, each time or each step, we are going to increment the column index by 1. And then after we change direction, for example, from 3 to 6 to 9, so each time we fix the column index, and then we increment the row index. And then if we are walking along the last row towards the left, we are going to remain the row index and decrement the column index. So this can be way of traversal can be retrieved using rotation matrix. So assume that we regard dr dc as a direction or column vector, and then if we rotate this vector around the origin by 90 degree counterclockwise, so this will be the rotation matrix. So in other words, if we use matrix multiplication r times the vector dr dc in column format, so we are going to get the result direction. So here the direction is counterclockwise 90 degree each time we change, right? From here to here, and then from 6 to 9, then 9 to 8. So this corresponds to a matrix R that is given by 0, 1, negative 1, 0. So actually just need to replace the A to be negative pi over 2 to get the rotation matrix. And then if we do the multiplication, the rotation matrix times the dr dc as a column vector. So we're going to get dc negative dr. So in other words, so if the original direction is dr dc, then after we change direction each time, no matter where, so the next direction will be dc negative dr. So this way we are going to we can easily get the next element to add to the result. So with that said, we are ready to write the code. So first I'm going to get the m and n's, so the number of rows and number of columns. So notice that I have changed the matrix to be capital M, so this is just for convenience. And then we're going to initialize a result variable. This is an empty list. It's going to hold the elements we visited during the process. And then the original direction, dr dc, because we first travel along the row direction towards the right. So we are going to increment the column index by 1. So this is direction. And then we need to visit site, so to avoid repetition during the traversal. And then we need to use a stop condition. So we are going to use a while loop, and we know a priori we need to visit m by n elements in total. So once the count is less than that number, we're going to continue. So the original position is nothing but rc equals 0, 0, right? So with that done, basically we're ready to do the while loop or traversal. So while count is less than m times n. So if this is the case, first we're going to append the current element, that is mrc. So now rc is visited, so we're going to add this element as a tuple to the set. So the tuple is hashable, right? So or immutable. So we do this, and then we are going to increment the count variable by 1. And next we are going to check the next element. So then the next element will be r plus dr and c plus dc. So basically we need to check if this new position is inbound and not visited. If it's not, so actually we need to adjust the direction. So let's check if this r plus dr is less than 0, or r plus dr is larger than or equal to m, or c plus c is less than 0, or c plus dc is greater than or equal to n. So this is the outer bound condition. Or if r plus dr and c plus dc are invisited. So if this is the case, basically we need to change direction. So we know the direction change will be dr dc equals dc negative dr, right? So after we change direction, so we can actually go to the next position. So the next position will be r equals r plus dr, and c equals c plus dc. If you like, you can write this in the one line, right? So after this while loop, basically we finish the traversal. We just need to return the result state. So this is the whole logic. Here, this part actually is analyzed here, right? Or you can just look at the conclusion here. So with that said, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let's make a brief comment about this method. So here we explain this method is mainly due to the fact that this method is of general use. For example, in this problem here, we are doing a spiral order in a clockwise fashion. What if we do this in a counterclockwise fashion? Then start from 1, then first move to 4, then to 7, then to 8, to 9, then to 6, and so on. So this can be easily coded by adjusting the starting position direction, and but the main logic remains unchanged. So this is the one comment. So another comment may be that there are 4 spiral matrix traversal problems in LeetCode. So actually we practice all these problems. You can follow up in my playlist for the other problems, or you can find other application cases of rotation matrix. So with that said, basically that's about it for this video. So you're welcome to comment and follow up me with other problems. Thank you.